Communications networks are vulnerable to extreme weather, such as lightning, floods, and high winds. Maintaining them under these harsh conditions is resource-intensive, expensive, and often dangerous for the teams who keep the networks running. When Hurricane Florence hit the US in 2018, we were trialing self-optimizing networks with Verizon. As the winds worsened, the decision was taken to test zero-touch network operations under these escalating circumstances. As staff left for safety, network control was given to our revolutionary cognitive capabilities. Could artificial intelligence and machine learning 1. Run the network without human intervention, 2. Compensate for the damage and keep the service running, 3. Proactively improve customer experience. Zero-touch network operations were proven as service was maintained while operational costs and network complexity were reduced, ultimately improving customer experience. In the future, all networks will work this way. Our cognitive capabilities reason and coordinate AI agents through the network, continuously learning and using an understanding of intent as input. This is the beating heart of our zero-touch cognitive networks approach. We are combining AI and cognitive algorithms to automate networks with minimal human intervention while keeping people updated. The following cognitive use case is made up of 5 key components: intent-based orchestration, closed-loop service assurance, AI explainability and machine reasoning, cell shaping, and autonomous drone inspection. An industry-leading communication service provider wants to stay ahead of the competition and increase revenue by launching a new video conferencing service. The intention is to have 80% of users receiving good quality of service. Our cognitive capabilities seamlessly translate this intent into sub-intents and measurable technical parameters. The cognitive capabilities define, assign, and activate the network components needed to deliver the conferencing service. The orchestrator triggers closed-loop service assurance and monitoring, adjusting network resources to maintain the good quality level. The network automatically reconfigures to maintain the service and meet the expected quality standard. The day has come. The service provider's new video conferencing service is activated, but the quality cannot slip even a tiny bit. So closed-loop service assurance monitors and assures it in real time. If the service dips, our cognitive capabilities instantly instruct configuration changes and additional resources to raise it. This is something it can do for multiple different services at the same time, while AI and machine learning manage conflicting demands. The new video conferencing service is a roaring success, so why stop there? The service provider now wants a premium product. The bar is raised even higher as they want 90% of users to experience excellent quality of service. No problem. The network resources are already in place. Closed-loop service assurance merely has to tweak the configurations and network functions to attain this higher quality. But what happens if quality slips and nothing the service assurance system does can bring back the expected level? No problem. AI explainability comes into play. Using AI and machine learning, AI explainability analyzes the service fault and determines possible root causes to help the service provider pinpoint and resolve the problem faster. Over time, the system learns to read the network and its analysis becomes more and more accurate. End users are ecstatic, and the service provider is delighted with the new excellent video conferencing product. But high winds take down the new service at a specific cell site. This time, due to the suspected damage to the network, closed-loop service assurance cannot recover the service to the desired quality, so it escalates to AI explainability to do its thing again. With an ever-expanding knowledge of the network and performance built in, it analyzes the fault and determines with 95% certainty that an antenna cable is damaged. Two things now happen. Firstly, surrounding adjacent cells use safe, reinforcement learning-based cell shaping to change frequencies and adjust antennas. This automatically fills in the coverage gap until the problem is resolved. Secondly, an autonomous drone programmed to investigate the site, starting with the antenna cables, is dispatched. It quickly spots the broken cable, and a human repair crew swiftly fixes the problem and service resumes. This is game-changing, cutting the time to repair faults and restore service levels. Our zero-touch cognitive networks vision is the future of network operations and will greatly reduce operational costs while improving fault resolution and end-user quality of service. Partner with us and take your first step towards zero-touch cognitive networks. Many AI agents, many combinations, many more possibilities.